All right, so now we're going to go on to our second type of probability that we're doing in this unit. It's called conditional probability. And it's just saying they're going to give you a condition and you're still going to just find the probability the same as we did before. So here's the definition. It says, if given events A and B, conditional probability is the probability that event B occurs knowing that A has already occurred. Okay, so it's kind of like those, if you ate this Snickers bar, we already know that you ate a Snickers bar, so take it out. Already occurred. Okay, notation when we say it, we write it like this. The probability that B has occurred right here, given, there's our given, that A has already happened. So we know that A has already happened. That's how we write it though. All right, so let's look at what this means when we're doing a word problem. It says Mitchell drew a card. Let's look at example 1. Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? So basically, you know the card was red. That's what we know. So you don't even have to worry about any of the black cards. You're just, actually, let's even do this. This is going to be the probability that A and B happen given that the probability of A has already occurred. So we're just going to go through and we're going to say, okay, how many red cards are in a deck of standard playing cards? Well, if you count them all up, there's actually 13 cards of each suit. So there's 2 suits that are red, the hearts and the diamonds are red. So 13 plus 13, there's 26 cards in my deck that are red. Okay, so that's the total number of favorable outcomes right there, or total number of outcomes it could be because we know that it's red. We want to know the probability that he drew a queen. Well, again, you're only looking at the red cards. Don't look at all the queens in the deck. Look at how many are A and B. How many are red and queen cards? Well, there's the queen of hearts and there's the queen of diamonds. So there's just 2 right there. So your probability would be 2 over 26, or you could say 1 over 13 would be fine. You could even plug this into your calculator and do 1 divided by 13, which is 0.077. And that's your probability. Okay, let's look right here on example number 2. This one we're going to draw I like Venn diagrams. You could also draw a table. We're going to get into some tables later, so I'm going to leave the tables for later. And I'm going to draw a nice, lovely Venn diagram, kind of from like we did in last lesson. So we've got 30 students, so we're going to put 30 numbers in here eventually in Mrs. Smith's math class. 13 are athletes and 9 are in band. So we've got this nice, lovely, we'll just call it A for athletes and B for band. Okay, before we put our numbers in, before you put 3, 13, and 9, remember there's a few places we could write those numbers. This is going to be important. It says 3 of the athletes are also in band. Okay, so there's 3 people that belong in both the athlete circle and the band circle. So those 3 get to go right in the middle right there. Okay. Now let's go back to our original numbers. 13 are athletes. So in my athlete circle right here, I need to have 13 people. I've already got 3 of them right here. So I need 10 more. These have to add up to my 13 athletes right there. Okay, 9 people are in band. So my band circle here, I need 9. I've already got 3. So I need 6 more right there. Okay, now there's some people out here that are in Mrs. Smith's math class that are not athletes and are not in band. So remember, there's 30 students. So what I'm going to do is I'm just going to take my 30 and I'm going to subtract these 10 athletes. I'm going to subtract the 3 athletes that are also in band, and I'm going to subtract the 6 that are in band, and I have 11 students that are neither athletes or in band. Okay, so there's just kind of a representation of all this. Now it says that one student is chosen at random. So we're going to just grab one person at random. Find the probability that the student is in band. So we want the probability that a student is band given that they are not, so there's our little complement, not an athlete. So on the bottom here, we have all of our people that are not athletes. Okay, so in fact, I'm just going to take my pen right here and I'm going to cross out all my athletes because I'm only caring about the people that are not athletes. So don't even worry about those 13 people in there. So how many people are not athletes? Well, there's these 6 that are in band. There's the 11 that are not band or in athletics. So 11 plus 6, there's 17 people left right here. Okay, what's the probability that of those people right there that we choose somebody that's in band? So these 6 are our favorable outcomes. Those are going to be in the top right there. And you're done. That's just the answer, 6 divided by 17. You could also, again, plug it into your calculator. That is 0.3529, so we'll just round it to 3. That's the probability. All right, we'll do the next examples in our next video.